In this video, I will discuss strategies and show how to set up a FieldTemplater experiment to calculate a set of pharmacophore hypotheses. FieldTemplater is included in Forge. The idea behind FieldTemplater is that molecules which are active at a target site, even though they may be structurally very different and characterized by different chemotypes, should establish similar interactions with the target, resulting in common field point patterns. FieldTemplater is used when there is no binding mode information available. It searches the conformational pools of the input molecules, looking for those conformations which share a common field pattern or a consensus alignment, and then stores those as potential bioactive conformation hypotheses. Those potential binding conformation hypotheses can then be used as a pharmacophoric template for aligning molecules. To run a FieldTemplater experiment, you can select and promote structures from an existing Forge file, or you can use the wizard. Including a highly active and relatively rigid compound among the input structures further increases the chances to obtain highly informative templates, as it reduces the size of the search space. I will use the wizard. I'll choose New Project, then click Create a Pharmacophore using FieldTemplater. I'll give my template a name, then press Next. Now I have to bring in the molecules that I want to use for templating. I'll bring in 4 files that have the conformations for a set of CCR5 inhibitors and press OK. This loads each molecule with its conformations into FieldTemplater. Now I can copy-paste the structures directly from a 2D drawing package or import via SD or Mol2 file. If I have the conformations already populated, I can import those conformations to save calculation time. Ideally, there should be between 3 and 5 molecules that are relatively small, as highly active as possible, and structurally diverse. When there is structural diversity, there is likely a smaller number of conformations which share a common field shape pattern across the input structures, thus increasing your confidence that the best scoring templates may actually be representative of the bioactive conformation, and further that their common field pattern represents the interactions with the target site. In the next panel, I have the option of setting pairwise constraints, which allows me to force specific parts of the molecules to align with each other. I'm going to skip this and press Finish. Now I have the option to decide how the alignment and templating is done. I will select the defaults for this case. However, with FieldTemplater, it is often the case that tweaking the experimental conditions can help achieve better results. It is now up to me to use the combination of the alignment score, my previous knowledge, and ultimately my chemical intuition to select a template that I will carry forward for a Blaze virtual screen or to use as a reference for an alignment and SAR analysis within Forge. If you have any questions or would like more information about FieldTemplater, please contact support@cresset-group.com.